Good morning, everybody. My name is Steve Wisniewski, and today we're going to be talking a little bit about the installed parametrics, everyday parametrics that come with SDS2. As you guys may know, there are several parametrics that do come installed with SDS2. For your use in modeling here, you can find all those parametrics in your data directory. If I just browse to my 7.3b data directory, in your macro folder, there's a folder in here called examples. All these files in here are the different parametrics that come installed with SDS2. Some of them you may see have multiple version numbers. You come down here and take, for example, the nailer holes here. I have version 1.10, 1.11, and 1.12. A good general tip here is generally going to be that you're always going to want to run the highest version possible. Most of the time it's going to have the most functionality and the most bug fixes built within it. That being said, depending on what version of SDS2 you're running, some of these may only work in newer versions. So if you are running an older version, you may have to run an older version of the parametric. And as well, there may be times where there might be a bug in the newer version. And if you find that you're having troubles running the highest version number, try to roll back to a slightly older version and see if that one gives you a little bit better results. Now, with that being said, most of these parametrics as well are written by customers of ours. They're not really upkept or developed by anyone here at Design Data, but the customers have gave us the okay to distribute them with our software. A lot of times, if you go through and you need help, let's say it's a weekend, a holiday, or anything else, and you need help or just some tips on running a parametric, pending who wrote it, pending the author, they may have went through and provided different tips and or notes right within the actual parametric file itself. So a good spot to look for if you're having troubles running a parametric is just going to be right within the file itself. Take, for example, my beam clips. I'm just going to use a standard text editor here to open that. So I'm going to open it with WordPad. You could use a Python editor. Like I said before, most of these are written by other customers of ours. Here at the very top, you can see it's written by Bruce Vaughn. Not for sale, and it's provided as is without any warranty. Down below, he sort of gives a little description of what it's supposed to do. This particular parametric is going to go through and add clip angles at the web of the end of a wide flange channel or tube beam that frames into concrete, or it can add the monorail clips to the beam webs. If you scroll down, you can also see, like I said, this is all depending on who wrote it and how descriptive they wanted to be right within the file. You can see all the different updates for each version and what that version added in there. And then after you scroll down so far, you'll get to the bulk of the code. And like I mentioned before, pending which parametric, you have a note right here in this one, not compatible with SDS2 7.0, whatever else. So if you are running 7.0, this particular parametric cannot be able to run. So throughout, I guess, today's webinar, I'm going to be going through several of these parametrics, but like I said before, not all of them. When I go through and run them, just so you guys know, like I said, I'm not going to go through every single one of these, but I did go through, and I have actually placed all the parametrics that I'm going to demo throughout this webinar in this particular webinar parametric folder, just so to speed things up so I can easily find each one that I need to go to. So like I said, just pointing that out, and I'll show you how to run them here in just a second within modeling. So I've got a little model here opened up, and like I said, we're going to go through, and I'm just going to demo the different parametrics. I'm not going to go real in depth into each one of them, but just give you a good idea that they exist and what they could potentially be used for. Start off, how do you run a parametric? And for that matter, what is a parametric as well? Before we get into running one, I guess we'll describe what a parametric is for those of you that don't know. All a parametric is, it's a Python script that can be used to run in the modeling for creating members, materials, bolts, holes, or welds, and it can also be used to read and update different member and material attributes such as your custom properties. With that being said here, the first parametric that I'm going to run is going to be a creating of an RFI parametric. It's also going to update and write to some of my custom properties. So to run a parametric, there's going to be three methods. Through your model pull down, we have parametric and run. Notice there next to it, my hotkey is OP. Or down below, I have my parametric run, looks like my standard tree, with the plus symbol on it. I can use that to go to parametric run as well. From there, like I said, I'm going to browse to my data directory where my parametrics are stored at. In there, I have my macro folder. Like I said before, all the default installed parametrics are going to be in your examples folder, but I'm going to be running out of the webinar parametric folder that I created here. It has all the same files, just a different location. And the first parametric that I'm going to go through and run is going to be called this Create RFI version 7304. Let's take, for example, it's just going to basically ask me up now at my status line, select members to include. I'm going to select my members. Maybe I need somebody to review this connection into the flange. So just as I'd create an RFI in the past, select my members, locate my reference point. I'll call it RFI1. Put in, we'll say today's date. We'll respond by tomorrow, please. And let's go from there. Subject, we'll say review flange connection. Let's call that good for right now. So pretty basic so far. We're just creating an RFI. That's all we've been doing. Put it on my desktop. Give it a name. No need to open that. Put in my initials and the select which RFI to be populated. Like I said, if you are using the design data flavor files for the custom properties, you have different RFI tabs within your member edit screens. And I'm going to apply this or populate RFI number 1. Now it's going to prompt me which members do I want to apply the RFI information to. I'm only concerned about this beam into the column flange, so maybe I'll just select the beam, right click and hit OK. Parametrics completed. From here, maybe I have a status display created that I can go through, and it's going to show whenever I have a RFI1 set to be an outstanding RFI. Go ahead and apply that. Now I can go through, color code my model based on that custom property. Like I said, Parametrics can read and update custom property or member attributes here. If I edit that particular beam and go into my properties, I have my RFI1 set to be outstanding. Reference 1's what I assigned it. I filled in my initials, date of creation, and respond by tomorrow. So that's just, like I said, one parametrics that's going to go through, run an already simple command of creating an RFI and updating the member attributes of the custom properties that I can then bring in status display and utilize. The next connection, or the next parametric we're going to go through and run is going to be a bent plate pour stop. I'm going to actually run this a couple times here just to show two different examples of it. And for this first example, I'm just going to surface on top of a beam. And I want to go through, in this first example, I'm going to add in some field attached bent plates, pour stops, all the way down grid line 1 here to grid line D. So to run it, once again, I'm going to go to my parametric run. And here at the top, beam bent plate pour stop. I'm going to run the highest version of it. I'm going to hit yes to the defaults. Go and save that. Select the member I'm going to attach it to. And now it's going to prompt me to select the left and right end returned. I'm going to go through and use my offset points on this. And we'll start from here over to grid line D. From here, some of these parametrics, depending once again on the purpose of the parametric, could be very simple, or some of them might get a little bit more complex, and then the amount of fields that may need to get filled out. Up at the top here, we have a few different values. Like I said before, I want to set this to be a field attached. The type of material, the L is going to be standing for bent plate, not angle here. We have Z's, channels, or 2 plates. We're going to leave it set to bent plate here. When I specified my points, I got my setbacks from work point and slab edge distance. Maybe we'll go 12-inch horizontal, 6-inch vertical legs. From here, we want to be on the far side of the supporting beam. Down below, I do have the ability to break it, so instead of having one continuous plate, I can go through and specify that I want to have it to be maximum 10-foot lengths, and we'll say maybe a minimum of a 1-foot length of a bent plate. This parametric can also go through and provide different cuts and copes right around your columns. when it's going to be shop attached here. With it being field attached here, we're not going to get these cuts, but I'll show you a simple way here in a minute to get those cuts around it. Do we need to add in closure plates? Yes or no? And then this parametric will add in views of the beams that I have added. And do I wish to have any studs or DBAs added on this? A lot of times with most of these parametrics as well, there's going to be an images tab that'll go through and give you a brief pictorial of what this particular parametric is going to do as well. I'll hit OK. I don't need to add that again. And here I can see now, just by running that one parametric, I've got a whole line of bent plate pour stops running all the way down my beam line here. Like I said, they are field attached, so they are all individual miscellaneous members. With it being field attached, like I said before, it did not go through and automatically cope around my columns. But with my bent plates already in here, I can always use my fit command. I'll set it to cope, and I want to cope my bent plates around the column, maybe a 1/4 inch clearance, and call it good from there. So like I said, that's just one version of that bent plate pour stop parametric. Another good thing to know here is the ability to erase a parametric. If you do mess up on running a parametric, you need to rerun it, re-enter values so revision came back. You could go through and manually edit the materials and change it from there, or you could erase the parametric. So erase a parametric, very simple, just like running. Under your model pull down, we have parametric erase or IP, or down here with the tree icon with the minus symbol is parametric erase. I'll select my bent plate pour stop to erase. And yes, I wish to erase all members. And now I'm back to square one. Like I said, I'm going to add in that bent plate pour stop one more time, just to show a shop attached situation. Shop attached. We'll leave all the same values here. We'll go 12-inch legs. On the far side, we can still break it. The only difference here is I do want to go through and I want to have it. I'll do two scenarios here, cope to end on the left and minimum cope on the right-hand side. And let's go ahead and remove the vertical plates here in the scenario. Here you can see in this situation it did go through and automatically cope right around the columns there for us. And we can see the rest of the bent plates there, still broken apart into 3 different sections, but this being all shop attached to the beam here instead of being broken apart into miscellaneous members. So, like I said, that's going to be one parametric. Another parametric we're going to talk about is just going to be a beam bearing plate. Down below here, I do have a sample scenario here of a beam running into another beam. Maybe I just want to add in a quick bearing plate to this and have it cope around it. So in here I have a beam bearing plate parametric. Select my beam. Once again, we'll go through, add that to the left-hand side. Be horizontal or normal if the beam's sloping. The beam bearing depth, we'll leave that at about 6 inches. That's how far down this other beam is. Down below, and we'll go 6.5 inches for the clear distance on the left. And then my beam gauge, we'll say it's 3 inches. Bearing plate gauge 4 inches. We'll go through and add the holes. We can see in here, do we wish to cut the beam or cope the beam, yes or no? From there, just went through, added in the bearing plate and cope the beam. From here, all I need to do, mark my beam for processing, reprocesses it, and not get the bolts or holes there. Moving on, got a beam clip. So another similar scenario here. I have a beam framing into an embed plate into a concrete wall. I need to go through and add in a set of clip angles here potentially that's going to weld onto the embed plate there. So I'm going to run a parametric. In here I have another one called beam clips. I brought up the actual Python file of that here earlier. Like I said, I'm in this scenario, I'm going to add in the end clips. Go ahead and select my beam. Here where I can go through and specify different information, I'll go through and add them to the right-hand side. Both sides of the web. Do I need to rotate it? I can specify my information about the clip angle, the distance of the holes, and whatnot. Here I can change my clip angle size. Maybe I want to go a 4x4 by 3/8 in this scenario. I want to add bolts and holes. I can go through and change the parameters on those bolts and holes here. Do I need to add a bar washer? And then here's an image showing some of the different values within that. Quit. So here I went through. All right, I can see I made a little mistake. So now the easiest way, I'm just going to go through, erase that parametric real quick. And let's run that one more time. And let's see what I might have distorted there. Looks like I need to change this amount of connection projection here. So like I said, whenever you do find that you may have messed up on a parametric, you can just quickly erase it, go back, re-add it in there. That looks much better. All right. Moving on here. Demo another parametric. I'm going to add in a kicker gusset plate. So I'm going to come up here on surface on top. I have some fill beams over here. And let's just say I'm potentially going to have some different rod bracings, whatnot. I need to add in some kicker gusset plates up here to these beams. From here, I'm just going to go through and add in maybe a couple of particular construction lines. Just like so. Let's go back to my parametric run. And like I said, I'm going to add in a kicker gusset. Select a wide flange HSS beam. I don't need to add it to the rest of all four of them. Here, what information, what sides of the beam? Both sides, near side or far side. Maybe I'll go both sides here. Top or bottom of the flange, we'll go top. If the beam is sloping, do I want to go normal or vertical? And these aren't sloping, so I'll go vertical. Here I can specify different edge distances and so on. Where do I want the holes in that plate to be at? So if I need holes, once again, here's just showing a graphic image of what the plate's going to be added in like. Then hit OK. And from here, it's just going to ask me to locate the location of the gusset or return. So maybe I just want to add one right here. If I wanted to add more to this beam, I can definitely go through and set up more different locations as needed along this beam line and add them in there. If that's all I need, I'll go through and right-click, and I don't need to add any more. I can rotate around. There I can see I have a couple, like I said, gusset kicker plates in there. I could then go through and add some to the bottom here and top and so on down the line throughout the rest of these beams as needed. Or as we noted there before, I had the ability to select multiple beams there all at the same time, or have them add to the rest of the B95s. The next parametrics is going to be a real basic one. It's going to add some nailer holes here to a beam. I'm going to use this beam up here as B38 for my example. Here I have another parametric called beam nailer holes. Select which beams. Here I can specify top flange, bottom flange, both flanges, or the web. Maybe I want to go top and the web here in this scenario. The nailer hole pattern, staggered, non-staggered. I can fill out the parameters along those lines. Go through web hole information, distance, first row spacing. Like I said, just showing some of the different images here. And if you do only have a shorter beam, it's only going to add the two sets of holes so that are parallel right here on the ends. You're not going to have the individual ones, depending on your spacing. Once I hit OK, it adds all the holes, prompts me to select another beam if I want. I'll go ahead and select no. I can see real quickly there I have my nailer holes. Top flange, I can see them staggered. The web here, I can see them staggered now as well. And like I said, I could always go through and adjust the spacing on those, or if I even wanted them staggered in the first place. Moving on, another parametric is going to be maybe I need to notch a beam web. Down here I have a scenario of two beams that just physically intersect each other, but potentially I need this top flange to continue on, but I want to notch this around it, potentially cope out the rest of this bottom flange. We could always do just a big cope plane, with a on the end preps of that beam, or I can come in here and I can go to my beam notch web, select my beam to notch, select my supporting beam. Here I want to notch the side of the supporting beam, basically the far side being this side here. Go to the top. I can specify my cope information here. Attempt to cut beam web. If I set this to yes, it's going to actually cope this around it and cope out that bottom flange. If it was no, you'd have something more along these lines here. Like I said, if it is yes, you can see what it's going to give me here. Go and hit OK. Don't need to cope anything else. And there I can see it's went through, notched right around the flange, and then coped out the rest of the beam scenario. All right. Another parametric that's commonly used that I see quite a bit is going to be the beam outrigger shape. Just come up. We'll use this particular beam here. I'm just going to surface on top. Potentially, I guess before we get to add it in, this outrigger, maybe I want to have the X amount, maybe 7 of them, 7 different spaces in here. And I want to have them be evenly spaced. What's an easy way I can go through and find that information so I can add in these outriggers? Now, I could go through and figure it out the longhand, or I could just come in here. There's another parametric that I'm going to quickly show. It's going to be the cons array linear. It's going to just prompt me to pick 0.1, 0.2, and then if I want these lines to be perpendicular to those 2 points, I'll select a line perpendicular. And all this is going to do is going to go through and add in construction lines for me. I can go through and give it an even spacing down here for even spacing options. How many spaces do I want? I mentioned 7 before. So I can see the pick distance is 25 feet apart. I want 7 spaces between that. Just went through, quickly added in all the construction lines needed for 7 spaces. Now, like I said, maybe I want to add in the outrigger to each one of those construction line intersection points. Locate my wide flange beam. No. From here, like I said, what side do we want to add them on? I'm going to go through and add them on the far side, so they're going to kick off to the left. What material type do I want to have used here? I can go through and specify an angle size. Maybe here we'll go, I'll say an L 6 by 6 by half for an example. What length? Maybe we'll go 2 feet out. Whether I need to offset that up or down at all. Do I need to specify any holes in here? If so, how far out? Maybe we'll go 22 inches out to the farthest hole. And then we have a couple hole columns here. And then 3 inches between that spacing. Hole type and hole information. We'll go short slots. Here we have other information for your material grades and images and so on. But I'll let you guys go through and take a look at that at your leisure. From here, locate where I want it to be located at. We'll say maybe here, 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 and just work my way up the line until I get them all in there. Don't need to add any more. There, now I can see I have all my outriggers quickly placed onto this particular beam with the short-slotted holes placed within there. So just a quick way to add in your different outriggers that are potentially needed. And you could specify any rolled shape in there, whether it's a wide flange or WT or angles. Another just quick parametric that you can go through and run is going to be a reduced flange, or also known as a dog bone. How can we go through and add in that information? Just get a reduced flange scenario here on a beam. Well, once again, within our macro examples folder here, we do have one called beam reduced flange. Select my wide flange member. And really here, what ends do I want to cut? The left end, right end, or both ends of this beam? We'll specify the left end. The number of vertices, basically how smooth do you want that roll to be? We'll leave that at 32. Distance from left end to start a cut, 1 foot. Length of radius, we'll say 2 foot. And then the depth, we'll leave it at 1.5 inches. There we can see we quickly got the reduced flange scenario on this left end of this beam. Like I said, I did not specify the right hand side. Like I said, very basic, but can be very, very useful and save you a lot of time instead of trying to model in something to fit around here, or potentially doing some type of cut layout to make those cuts on this. Another scenario, and this is actually just noticed this requested here earlier today, is going to be maybe I need a beam splice that's going to be a single-sided welded bolted scenario. I'll write down here I have a sample situation. I do have a parametric in here called beam splice. I'm going to run the version 2.0. Select my beam. Oops. Come back in there. Beam splice. Come back in here on that. So that back to try that here one more time on that one. I tell you what, we'll just come up and model in just a couple other beams here really quick. Set the point in connection. And same scenario over here on the left. There we go. Now, like I said, which splice plate to which side? We'll say just the near side on that one, will right end. I want this to be a welded scenario. I'm going to lap that over 6 inches. What type of information for the holes do I want? Maybe just short slotted. The plate information that I can specify if shims are needed based on different web thicknesses. And from here, I just click OK. Now I can see I quickly got a welded bolted near side only splice connection. So like I said, a very simple parametric to go through and run. Moving on to the next one here. This is going to be another very simple, very basic one. Just going to be a basic beam stiffener parametric. Let's take for an example here. I have this scenario with this column sitting on top of a beam. I could go through and I could edit the member and set it to use the transverse beam stiffeners. But in this time here, maybe I want to run the parametric to do so. Just so you can get an example of it. I'm going to run this beam stiffener. I'll try that here. Like I said, if you do have to, you can always roll back to an older version of it. There we go. Select my beam. If I wish, I just optionally select a column. I want to go single or double stiffeners. Which sides? We'll say both sides here on this situation. If it's anything's rotated or sloping here, I can go vertical or normal. From here, I can go through and put in calculated differences and go from there. Here, I also have my depth options where I want the top depth half or whatnot. I'm going to just go full depth here and hit OK. There, I can quickly see. I know I've just got a couple beam stiffeners right there based off that column. Let's go to another scenario here. Maybe I need to go through and add in a connection here to the Hip and Valley ridge beam here. I want to get in maybe a bent plate connection from this column to the beam. In my macro examples folder, I do have a column bent plate connection parametric I can go through and run. There we go. Let's prompting you locate a wide flange or tube column. Locate my beams. Right click and hit OK. what type of connection do I want? Conventional, hooked, wrapped, hooked, wrapped. We'll go with the conventional. I can change my connection information. We'll go 5 bolt rows, 4 inches against the leg to the column. I can go through and specify different information about the bolts and holes. From there, I can hit OK. Continue yes. And I'll hit OK on that one and go through and just reprocess this. And there I can see now I quickly just have a bent plate connection that the system otherwise did not design for me. So like I said, just another quick parametric that I can go through and run. And while we're working right here on this hip and valley beam, maybe I want to add in a hip plate going down this particular ridge beam here. I'm going to just come in here, surface on top of it, and we'll throw in some construction lines. And like I said, I just want to add in a quick hip plate here to the top of it. So down here at the bottom, I have one called 7.1 beam hip plate. Select my particular beam. I can go through and specify my different parameters that might be needed on this. We'll leave it set to match toes. Hit OK. That width looks fine for me for right now. And I'll select my start point. We'll just select the end of the material right on the center. And then for my end point of this particular bent plate, we'll just come down to here. And now if I zoom back in there and rotate around, I can see I now have this hip plate running all the way down, and it's broken down into 10-foot increments here. So like I said, another just quick parametric to help you guys save some time and quickly get that information in there. Moving on to the next parametric, we're going to add in we're going to bolt a couple flanges together that the system wouldn't normally do. So here I have a particular scenario where I have a couple beams framing over the top of another beam, and I want to have the system go through and bolt all this information together for me. So I'm going to come in here. I have bolt flange to flange. I'm going to bolt beams. Select my beams to bolt, and I want to bolt those to this particular beam here. Go through and specify my different pattern information, the direction, whether tension controlled or not, and then the particular hole types in each one of the members. If there's a filler plate needed, I can go through and specify some information about that, of the grades and the colors. And from there I can hit OK. So went through quickly, just went through and added a couple holes, couple bolts to each one of the beams down into this other particular beam's flange. Moving on here, we have another parametric. Let's say for an example, I want to go through and I want to prep one of these columns here to get for welding here. Well, I have another parametric within my macro examples folder, column flange prep outside. I can go through and run that. I'll select my particular column I want to run this on. Specify which ends I want to go through, and I want to do the bottom ends of this particular column. Specify my angle, flange setback if needed, my axis hole information, the height and length and radius. If I want to see an image of it, we can see the image. There is a notes back here to use the chamfer tool to prepare the column web, and we can see that that particular cut here is not done by the parametric, but to use the chamfer tool to put that cut in there. And there I can see I quickly just went through and got my columns prepped there for welding there with my entering cut and my flange preps there. Very similar to a parametric we ran here earlier. For the beam stiffener, there's also a column stiffener parametric. If I go through and run that, there's one called call RF stiff. Select my wide flange columns, and then select a beam joist or horizontal brace that frames into it. Here, This particular parametric has the ability to add in extended shear tabs into the flange if needed. I'd specify another beam then afterwards if I would set this to yes. Stiffeners at which beam flanges? We'll say both sides of the column. I can specify my different alignment operations if I need to offset those up and down at all. What stiffener size to apply. Let's go through and just use it the column A information. Or I could put in a user values and I'd specify a user width and thickness as needed, but I'll just use let the parametric calculate the correct width of them to go out to the flanges. From here I can also go through what type of preparation do I want to have in there, cope or clip. We'll leave it as such, hit OK. There I can see I quickly got a couple stiffeners placed into the column based right off of this beam that I had selected here. Alright, moving on. We still got a few more parametrics that we're going to cover here. The next one that we want to go through and show that it's possible, is going to be our column safety holes. Take, for example, I have this line of columns coming down here. Looks like C1, C7, C8, and C6. I want to go through and run safety holes throughout all of those. So I'm going to go back to my parametric run. Here I have my column safety holes. And it's going to ask me select my columns to receive the holes. So I'll select all 4 of these. And now select the beam or joist members for reference elevation, just so it knows where the floor is actually starting here. So I'll select this B18 here as my reference elevation. And here we can see at the top it's going to add safety cable holes to column number 1 of 4. And you can see that the far left one here, the first column that I had selected, is highlighted here. So I can add safety cable holes, yes. Do I want to add lifeline holes, yes or no? Which column face do I want these holes to be added in? In this scenario here, for this particular column, maybe I want to go face B. Here I can go through and control the column gauges as needed. I can also go through and adjust my hole patterns that might be needed here on this one. My floor thickness, distance, the first cable hole, and then the center to center between safety cables, 1'9" as well. And if I had lifeline holes, I go through and specify the distance of those. And then for the hole patterns, I can go on near side gauge or far side gauge if I'm going into face A or C, and into face B on center line. Both gauges, left or right gauge. We'll just leave it set to on center line for right now. Hit OK. Like I said, that was the first column. Second column, I'm also going into the web, so we'll just leave everything as such. The third column here, though, I'm going into my flanges, so I'll go through and change this up to faces A and C versus B. I'm going to hit OK. And then the final column, going back into the web, so I'll go back into face B. Hit OK, and I don't need to add these to any more other white flange columns. And from here I can see I've now got 2 safety holes in each one of these columns. This particular parametric will only run with will not run on your tubes and your pipe columns. There's another parametric that we can run. It's going to be your column safety tabs parametric if you're running those on a particular pipe or tube column here. So I have a line of pipe columns here that maybe I want to go through and add in some safety tabs to the backside. These columns are rotated 0 degrees, so my B face is going to be here to the near side of me. Go back, bring up my parametric run list again, and I have my column safety tabs right within here. Same as before, select wide flange pipe or HSS columns to receive the tabs. Select a beam or joist member for the reference elevation. I'll just go ahead and select this beam here. And here, very similar to the previous screen, it's going to give you a little bit more information about the tab, the plate sizes and whatnot. For these particular ones, like I said, I wanted to add them to the near side, so we'll go face B here on this one. I could go through and specify maybe another checkbox on each one. Notice here once again, just as before, it's saying add safety plates to column number 1, and only that first one's highlighted. So potentially I want to add one on this particular column to face B, and over here out to that side to face A. Down below, like I said, I can go through and adjust my tab length and tab width. Maybe we'll go 4x4 on those. And then my hole gauge on the tab will say 2 inches. If I need any offsets, I can go through and specify, and here's what a similar detail is going to look like on that. Now I'm prompting me for column number 2. This one's going to be one of the, I won't say interior, but not on a corner here. So I'm just going to go on face B, leave everything else the same. Notice the values did get retained from the previous entry, so I don't have to go through and re-input the values each time. Column 3 is going to be the same. We'll just go face B. And then finally on this column 4, maybe I want to go B, and then I also want around the corner, so maybe I'll go over there onto face C here as well. Once I'm done, it'll prompt me if I want to select more wide flanges, pipes, or columns, or HSS columns. I'll select no. Here I can see now I have 2 sets of safety tabs on each one of these columns. Like I said, just another quick parametric. They don't add a whole lot of materials. They don't do a lot, but they just add that little bit more to make your life just a little bit easier, make the modeling process go a little bit smoother for you. The next parametric here that I want to demo is just going to be an HSS Cap parametric. I'm just going to add basically a cap plate to any HSS material. I'm going to run this example on this particular HSS vertical brace here. What I want to do, I just want to add in a cap on either side of this gusset plate, but I don't want it to interfere with the gusset plate. If I come into my macro folder, I have a parametric HSS Cap. Select my HSS membered cap. Go and select this particular vertical brace. Which ends? Both ends, left end or right end. We'll specify both ends on this one. The thickness of this plate, we'll leave it at 1/4 inch. Do I want to break the plate at tube notches here? Yes, I do. And if I want to offset the notch, offset the HSS notch one way or the direction, one way or the other, I can go through and specify that. Do I need to specify any type of cap plate setback here? And do I want to clip the corners here of it? And here, there are no images for this particular parametric. I'm going to hit OK. Do I want to add it again to another column or another HSS member? I'll say no for right now. And here I can just rotate around and I can see it just quickly added in. 2 separate plates here, one on either side of the notch. That does not interfere with a particular gusset plate there. And if I come up to the right end, I can see I'll look at the same plate up there. Well, nice, quick, easy parametric there. Let's take for an example now the same brace here. I need to add in a particular reinforcing plate onto the sides here of this horizontal or this vertical brace. Once again, something the system may not be able to handle right now, but we do have a parametric, the HSS reinforcing plate right here. Select my HSS brace members. Now I can go through and I can specify the location of those, or I can just return for to center the plates on the brace here. Now, which sides of the brace? Both sides, near side or far side. We'll go through both sides, and let's say maybe this only needs to be on the left end. Distance from left end to these particular reinforcing plates, maybe we'll go 1'8". I can change my different plate dimensions, 3/8 of an inch thick. Maybe we'll go 3 inches wide, 1 foot long, if I need to add any welds. And once again, we can add an image just sort of see what we're looking at there. There I can see it's went through and just quickly ran and added in those reinforcing plates on both sides. Now, like I mentioned again, just to reiterate this particular situation, let's say I needed to bring those reinforcing plates down a little bit closer. I could always go through and manually move the materials, or I can run my erase parametric, come through here. It's going to be a list of all the parametrics that I've currently ran that exist in my model. So here's my reinforcing plates. Maybe I want to erase that. And now the material's been removed, so is the welds. I can go back and reapply that and just basically run the parametric again, only this time adjust maybe my distance back down to maybe 12 inches instead of 20 inches there. There we go. Maybe that's what was called, or maybe a revision came back. Like I said, just showing how you need to go through and handle your different revisions or potential mistakes here and there. From here, moving on, there are different times where I've heard of scenarios where we need to go through and put bevels on all four sides of an HSS piece of material. Maybe you're getting some type of weld prep, full pin weld there to a cap plate or anything else. I'm just going to use this particular example for this HSS material here. I want to go through and I want to add in bevels to all four sides here. Now through your end preps, there's really not a way to do so on that one. But within, once again, my parametric list, I have my HSS wall prep materials. I'll go through and select all my HSS materials, go through it. It's been added to the list. I can go through and continue adding materials to that list as needed. If that's the only one, I'll right-click and hit OK. Very basic parametric compared to some of the other ones with all the extra screens. The prep angle, 45 degrees. Which end to prep, the left or right or both? It's going to be my right end of this column. The root face, 0.005. Just a quick image what we might get out of that. You want to select more. In this scenario, no. And like I said, we can see we easily got all four sides of that and the corners there beveled there for the prepping. So very, very simple parametric that can save you a lot of headache there trying to cut those manually. The next particular parametric that we're going to go through and run is just going to be a quick kicker angle. So we only have about 5 more parametrics to run through here. So back down to my fill beams here. Once again, maybe I want to add in those construction lines here. I'm going to quickly run that construction line array. Make those perpendicular. Even spacing, and I only want maybe 4 spaces on this one. There we go. And now, like I said, I want to go through and add in a kicker angle between some of these. So right down here, I have my kicker angle. Select wide flange beam or HSS beam. Here's one right here. Select another. Maybe that guy. What type of member do I want to add it in? Is miscellaneous or vertical brace? Which sequence? A lot of basic information here. What side of kicker plates? Near side, far side. Which point's the high point? The first point I select or the second point I select? So right now the low point's going to be 0.1. The high point's going to be 0.2. What type of material? We'll leave it at the 3x3 angle. We want it to be double material. Notice only it's for vertical braces. My kicker gusset plate material. This particular parametric will add in that kicker gusset. I can specify my information on that. Here I have my whole information, weld images, and then a different screenshot there. Once done, I'll just go ahead and hit OK. Locate point 1, select point 2, and maybe select point 1, point 2 again, and return. And just giving me user piece marks. That's fine for right now. Go through and process and create solids. And there I can see now I've got a couple kicker angles quickly modeled in there. I could have went through and went farther down that line as needed, and or I could have reversed the points that I selected, point 1 being here and point 2 being over here, to reverse the high and low sides on those. Okay. Another parametric that I'm going to run is going to be a quick knee brace. We'll open up a particular grid line here. Actually, is that the one we want to run? So let's come up here. to this one right here. So in here I do have a knee brace parametric. Select the left endpoint. Maybe we'll select on that line there down to, let's say maybe to here. Now we'll import the file. What type of material to use, the stem direction, and my bolt pattern. And we can see our 3 different bolt pattern options. We'll just leave it at 1 for right now and hit OK. Like I said, a couple of clicks of the mouse there, and now I've got a quick knee brace in there, the plates bolted on there, and the cuts on the brace material. All right, final couple parametrics that we're going to run. This next one's just going to be helping with selecting material for potential multi-editing and what else you might need to do with that. I'm going to open up my ISO view here again. I have a scenario set up, at least for one example of these combination of 3 parametrics. I have 4 identical plates here. If I hover over them, I can see they're P63. This particular one, index 378. Here's P63, index 379. Same thing with this one here. It's going to be 378 as well. If I was just come in here and edit this piece of material, and I want to do some type of cope or anything else like that on the top left-hand side, notice it's not really giving me the ability to change all of them. I can come in here and I can select material by piece mark. So I'm just going to run that, select my particular piece of material, selects all 4 of them, and then come in here, multi-edit, and go from there. Now I do run into a scenario here. You can see all the fields are sort of disabled or inactive. And that's going to be because the parametric went through and selected all materials that match that particular piece mark, regardless if they are on model complete or locked ends of members. This particular member here, B119, is set to a model complete member. So if I did want to run through and I needed to change these 2 particular plates, but I did not want to change those 2, I could always select both of those manually, or I could run a very similar parametric. And here I can see select material by piece mark, no model complete. Select my piece of material, and now I've got those 2. It excluded these other 2. I can click edit. I can come in here and make changes to these plates as needed now. And now I can see I just added a little cope on each corner for an example. And then if you noticed in there, I had one other scenario. Just as to show the example, I believe this beam right here, I do have set the left end to be locked, but it's not model complete. The right end is not locked. So I'm looking at these different particular shear plates on it, the F13s, and run that. Select my piece of material. You can see it's selected all my different materials. I have 10 of these selected, but did not select this particular F13 because it's on a locked end of a member. Like I said, I can multi-edit and do any graphical changes as needed from there. The final 2 parametrics that we're going to run, just going to be very basic ones, and all they're going to do is add views to members. Let's take for an example, I want to go through and add in the bottom flange view of maybe these 2 beams here. I could definitely isolate them and go from there, or like I said, we can write these parametrics, or you can alter them to add in whatever preset views you want. For this particular one's going to add in the bottom views. Select my members, add in my view. I'll select these 2. I can set my depth check in and out. We'll say maybe I want to go 3 inches in. We'll leave it at 2,000 out. Select no. Come in here and isolate it. I can now see I have a bottom flange view user created added to this particular beam. Final parametric is going to be a little bit more advanced view adding one, but it's going to be running on columns. View column, version 2.02. Let's come out here and take this particular column on this one. Here, like I said, instead of just always adding the bottom flange view, it's going to specify which preset views I want to specify. Maybe you want to go A, C, we'll top end and bottom end. I can specify depth checks here. Maybe I want to go 6 and 6. Hit OK. Let's go through and replace view C since that was already on there, and the bottom end view. And once again, I can isolate that from there. And there's all my other user-created views that I just had added in there, CA, the top and bottom end views. So like I said before, that's just a briefing over most of, or not all, but several of the installed parametrics that come with SDS2. If you were not aware that they were there before, or you were not aware what each one of them did, like I said, that was several of them. I encourage you guys to go through and test them out in your leisure time or in your free time there. And if you do have any questions, like I said, feel free to contact your support representative here, and or, like I said, you may need to contact the particular author of the parametric there as well for different help on that. Like I said, if you have any questions, go ahead and give us a call here at Design Data, and we'll answer any additional questions you have. Thank you. You guys have a great day.